To a user, opening a PDF takes less than a second, but for the person building the app, that single second represents a massive technical wall, requiring an engine that understands everything from font kerning to complex vector math. PDFs are not simple images. They are a set of geometric instructions. Displaying them requires the app to manage device memory, calculate vector paths, and parse text coordinates in real time without crashing the system. To handle this, Android relies on an underlying C++ engine called Pdfium, maintained by the Android open source project. It provides the low-level computational power needed to decode these files at the hardware level. But raw C++ isn't practical for most app development. That power has to be harnessed, wrapped in accessible commands, and translated so developers can use it without writing thousands of lines of machine-level code. In the native Android world, developer Bartosz Schiller bridged this gap with a library called AndroidPdfViewer. He took the raw C++ core and packaged it into a Java environment. His library automated the native tasks that previously had to be built from scratch, handling double-tap zooming, page snapping, and swipe gestures through a few lines of Java code. This library remains a standard today, updating its native architecture to support the 16-kilobyte page size alignment required for the latest Google Play compatibility standards. For developers writing in native Java or Kotlin, it is a comprehensive solution. But for developers using B4A, a rapid, high-level tool, this native library remains out of reach. A highly optimized rendering engine provides no value if it cannot communicate with the specific development environment you use to build your apps. The B4A ecosystem solves this through wrappers, translation layers that take native Java libraries and convert their functions into modules that B4X developers can understand. To bring PDF support to this community, a developer known as DonManfred built a bridge called PDFView 2. He wrapped Schiller's library and exposed its capabilities directly to the B4A environment. Through this wrapper, complex native rendering calls became intuitive B4A events. Instead of writing low-level graphics instructions, a developer simply reacts to a signal like Pdfium_load_complete. By handling translation in the background, developers focus entirely on their application logic. Wrappers expand the reach of a library. They take specialized, low-level features and deliver them to developers who specialize in rapid, high-level application design. Even with a functional wrapper, a document needs an interface. Programming toolbars, swipe logic, and page counters still require significant boiler coding. Community member Walt61 demonstrated the power of this wrapper by building PDF, an ad-free freeware viewer that functioned as a standalone, default-capable application. The final layer of this evolution was the B4XDaisyPDFView module. This transformed the raw wrapper into a plug-and-play UI component that can be dropped directly into a visual designer. This module automatically generates the user interface. It integrates the navigation arrows and page counts along the bottom toolbar without the developer writing a single line of UI code. A developer only needs to provide the file path. The module handles the internal PDF layouts, rendering complex tables and formatted blocks as they were intended to be seen. The end result is high-fidelity rendering, where vector illustrations and text alignment maintain their crispness regardless of the zoom level. This is the peak of abstraction. Hours of UI programming and hardware translation reduced to a single drag-and-drop action in the designer. This evolutionary timeline spans from raw C++ in the Android open source project to the refined visual components used in B4X today. This chain of custody lowers the barrier to entry. It allows solo developers and small teams to deploy professional-grade tools that would otherwise require enterprise-level resources to build. The manual work of managing memory allocation and vector geometry has been replaced by a single module call. Progress in software development is rarely about writing entirely new code. It is about packaging existing code so that the next person never has to solve the same problem twice. This journey from a C++ engine to a drag-and-drop UI is a microcosm of how open-source ecosystems survive and thrive. None of these developers worked in isolation. Each person built their solution specifically so it could be picked up and improved by the next person in the chain. The libraries and modules we rely on daily are the result of these stacked layers of community labor, most of which remains invisible to the end user. Writing code feels like magic today because a persistent community works behind the scenes to smooth out the machine's rough edges.